So I chose to do my presentation on data cleaning. And first off, what data am I actually cleaning? The data that I'll be talking about today is the data that came from my capstone project that I've been working on in a group of 4. And the ultimate goal of our project is to predict solar radiation. The University of Arizona has been collecting data from these different stations across Arizona. On this chart, a green dot means that that station is currently active, and a red dot means that it's not active. And they've been collecting data starting from 1987 to the present. So there's 38 stations, and some of them have been going on for 28 years. So if you imagine that each one has been collecting data for a year, multiply that by 28, and then keep adding those for each station, we have over 600 text files that we have to look through. So what are we going to do with all those? We have to combine them so that we can actually start analyzing the data. So now our goal went from predicting the solar radiation to we actually have to combine the data. So once you have the data in your program, that I was using JUMP, you can actually combine the data by columns. So in this example, you have year, day of year station, and air temp max. And you can tell the program, I want to combine things by column. So it'll say, okay, I'll match column 1 with column 1, or I'll match year with year. They'll look at the column name. So here we have everything nicely arranged by column. But then we ran across a few issues. In 1999, they said, we don't want to collect 2-inch soil temperature anymore. We want to start collecting 20-inch soil temperature instead. So for the same year in 1999, their row that was 2-inch started showing data that was 20-inch, and the 4-inch started showing 2-inch. So we said, how are we going to deal with this? We have to split that file for 1999 into 2 separate data sheets. There was also the issue that in 2003 they said, hey, we just want to start collecting this new data. First off, they started collecting reference ETO in a different way, and they just started collecting the actual vapor pressure and the dew point. So we had to deal with these new columns, which is okay because if you have those new columns at the end, the program that you're using will just say, okay, I'll throw these onto the data sheet that you had before. So that gave us new columns, and it also reordered our columns. So back to our map that we had before, some issues we ran across are, up here there's not really anything there, so if we're going to be predicting solar temperature that we don't necessarily want at a station, how are we going to account for those? Also, you would imagine that somewhere in the center, all of these points, maybe they'd have this close to the same solar radiation, and down here they would also have this close to the same solar radiation. So we said the original data file didn't have elevation, latitude, longitude, and month. They had different things related to weather. So we said we want to add these onto our data file. So we created columns for elevation, latitude, and longitude that they had provided in a different place on their website. And we added in month ourselves because if you think seasonally in Minnesota, it gets colder in the winter and warmer in the summer, so you would expect different solar radiation fluctuations throughout the year. Similarly, in Arizona, their months of August and July are their wet months, so they would have decreased solar radiation. And another issue we ran across was simply, what are we going to do if the data is just wrong? So in JUMP, you can do something nice. This is the recoding feature they have in JUMP, and here we're recoding by year, and we just said, how many days does each year have? And here everything was nice. Every year from 2003 to 2014 had 365 days. Great, that's what we expect. Except for the leap years, of course, they have 366. But some of the years, for example, in 1996, we noticed one of the years had a really low amount, and then there was suddenly the year 1984. And we knew that they didn't start collecting until 1987. So obviously for that year, there was something wrong with their sensors. Also, like this doesn't have it, but for some of the variables we had, for example, max wind speed, there were 999s for them. So that means that for that day, that sensor just didn't pick up that information. So by going in with the recoding, we can see that there was missing data from the 999s, and because there would be over 400 days in a year, we can say, okay, maybe that day was duplicated, and in fact there were a lot of duplicated days for certain years. So those are the problems that we had with our data collection, and after we've combined all this data, we've fixed the errors, we can now predict solar radiation.